So hello friends, so previously I have already discussed about Grignard's reagent 1,2 versus 1,4 addition. So if you have not seen those videos, you can see those videos. I have already uploaded 3 videos based on Grignard's reagent 1,2 and 1,4 addition, how the condition, all that I have already discussed. So now in this video I will start Aldol reactions. So first I will discuss about this problem which is already asked in GATE 2012. What is the major product? So they have given this reaction having this ketone and aldehyde group and treated with KOH, a strong base, and ethanol, that is the solvent. Based on that they given 4 options. So if you see, this is a ring closure type of reaction, that is intramolecular aldol reaction. So ring closure will be takes place and formation of, if you see 1, so there are 2 alpha hydrogens and 3, 1, 2, 3 alpha hydrogen. Based on that there will be formation of ring. So I will discuss everything one by one, which is more acidic proton, which is more electrophilic center between aldehyde and ketone, everything. So now I will move to the acidic proton. So there will be 3 acidic proton. I have numbered 1, 2, 3. Based on that they will give enolate, corresponding enolates, and attack will take place. That is, this negative charge will come here, then double bond alkene will attack to this electrophilic center, then this formation of severed membered ring will be takes place, and by the elimination of water molecule there will be formation of alkene, alpha beta unsaturated system will be takes place. So 7 membered ring are not favored, that is not entropy favored. So this pathway is not acceptable. So the option number D will be incorrect. So now we will move to this proton. So this when this proton will abstracted, there will be formation of Z enolate. So Z enolate will attack this alkene to this electrophilic center. So between this I want to share something, that is between aldehyde and ketone, aldehyde is more electrophilic than ketone. So attack favors in this direction, not this direction, because this is less electrophilic than this aldehyde. So attack will take place to the aldehyde, not to the ketone. So this option also not correct, and so the favored reaction is this, and the desired product will be this. So option B will be correct. I think that will be option B, right? Option B will be correct. Now I will move to the complete mechanism. Okay, so this is the reactant. When we give base, this will abstract this second proton and will form a Z enolate. Then this negative charge will become, and this alkene will attack to the more electrophilic center of aldehyde, and this will be abstract proton from water, and when abstraction of OH, that is proton from this, will form a enolate and then attack, then water will goes away and we will get this product. So this much is for this question. We will move to next question now. The number of aldol reactions that occur in given transformation is, so they have given an aldehyde and treated with another aldehyde, and in presence of concentrated NaOH, and that gives this product. So how many steps it will require to get this product? So this is very simple. If you know, this is a very common reaction, aldol reaction. So this aldol reaction first abstract this alpha hydrogen, then that will react with another aldehyde and the condensation product will be formed. So number of alpha hydrogen depends on number of steps. That means I will give you the complete mechanism. So here if you have 3 alpha hydrogen, it will take 3 steps to complete the reaction. So first it will abstract first proton, and then enolate will be formed, then that will attack to another aldehyde, and then product will be formed, beta hydroxy group, So alpha beta, so alpha position there are 2 protons, so another proton will be abstracted, then attack to another aldehyde, then water will be released and another proton will be abstracted, then another attack. So by this, if you see, there are 3 protons, so 3 abstraction, so the number of aldol reactions are 3. So by simply looking at the alpha hydrogens, we can predict how many aldol reaction will be takes place by that substrate. So here the answer will be 3. Now we will move to next question. The most favorable product obtained in the following reaction is. So this is also aldol reaction. So they have given 4 options. So option D is the correct answer. How I will tell you. So this is ketone, this is also ketone, and this is carboxylic acid. So this proton is more acidic, and so this OH will take this proton and form an enolate. That enolate will then attack to this carbonyl group and a 5-membered ring will be formed here. So now this OH and there is a hydrogen here that will eliminate water and give this product. Now if you see, if there is formation of enolate at this position, that will attack to this carbonyl carbon, that will not fissile because 1, 2, 3 3-membered ring are highly unstable. So this will not form. Now come to the next question. That is, in the given reaction, identify the correct combination of their major products P and Q. That is LDA, lithium diisopropyl amide. This is a bulky base. Take proton from less hindered side. So they have given this moiety having a carbonyl group, and this molecule have alpha hydrogen, and we have LDA and another benzaldehyde. So they have taken a cyclic one and a cyclic one, then the same condition, what will be the product? Based on that, they have given 4 options. So this is very important question because the stereochemistry is defined here, and always remember this question is very important for CSIR-NET and GATE point of view, because this required transition state model, and to understand that it need more time. So carefully observe how that Zimmerman Traxler model help us to determine the stereochemistry. I will tell you step by step. Okay, so first the LDA, that is the base, lithium diisopropyl amide, will take a proton from alpha hydrogen, so it will form a enolate. So basically cis enolate will be formed, that is Z enolate. Why? When it will be formed trans enolate? So that depends upon the base that we use. If you use very bulkier base, then that will coordinate to this, then that will be very repulsion to this methyl group and that group. So when there will be a huge repulsion, then only it will form E enolate. Otherwise there will be formation of this lithium enolate, that will be not that much repulsion, so it will form Z enolate. So Z enolate, remember Z enolate, it stands for this oxygen group and this methyl group that are cis to each other. So that's why Z enolate. Now it will attack, enolate will attack, negative charge will come here, and this double bond will attack to carbonyl carbon of benzaldehyde. So it will have this type of stereochemistry. How we will know that this stereochemistry will be predominant? That is, you can say this is cis, OH and CH3H cis. How to know this? Now we will apply Zimmerman Traxler model. We will take the benzaldehyde. You can see I have taken benzaldehyde in this position and pH at equatorial. Why I have taken pH at equatorial? I can take also in axial, but if I take in axial position this pH group, then that will be repelled by this tertiary butyl group. That is, the tertiary butyl group and this pH will be 1,3 diaxial interaction, and that will be not stable. So in Zimmerman Traxler model we have to see a stable transition state. So we will do heat and trial, that I will put pH here, then I will check whether there is any interaction or not. I will check that, and I will also take Z enolate. How to take Z enolate? If you see enolate, this is oxygen Li, so this is oxygen Li, then there is some double bond character, because this oxygen is coming here, then this bond is breaking here, so there is some double bond character here also and here also, and a new bond is forming between this carbon and this carbon. So a new bond is forming between this aldehydic carbon and between this carbon. So I have dotted this. Now if you see this Z enolate, how I have drawn this, because this CH3 and oxygen are in same side, that means either up or down. That means this CH3 and oxygen are in down. You can see this is down, this is up, this is down, this is up. So down will be cis. So oxygen and CH3 group are in down, so this will be favored. If I take this CH3 at this position, then that will be up and this is down, that will be trans position, and that is E enolate. So I don't want E enolate, I want Z enolate. So I will draw Z enolate, then tertiary butyl group will be here, and trans to that CH3 will be there, trans to that CH3 will there. This is down, this is up, so that will be also trans, and this is down, so this will be cis. So this model is complete. Now what will be happen? This bond will be shifted here, this bond will be shifted here, and this will be open up, and OLI will be formed. You can see this will be form a double bond O, then this bond is intact and new bond is formed like this, and OLI. Now hydrolysis takes place, this will become OH, and if you see the stereochemistry, tertiary butyl then carbonyl, tertiary butyl then carbonyl, then CH3 at back, CH3 is down, okay, CH3 is down, and if you see the OH, that is also back side. If you see the stereochemistry here, this is down and this is also down, so down means both are cis, so this is cis. And remember, one trick is here, if you see cis enolate, you will get always here OH and CH3 cis. If you take trans or E enolate, you will get here, that is trans, okay. So that is the trick you have to remember. Now I will show you this second, that is product Q. So if you see this first, that is the cis molecule, that is answer between A and B will be one of will be correct answer. Now we have to find the Q. So come to the next slide. As you can see, this LDA will be form a E enolate, because it cannot form Z enolate. The stereochemistry here, if you see this oxygen and this group, this bond is in trans fashion, so it will be E enolate. So from E enolate we will get anti-product, this is the trick, and for Z enolate we will get syn product. So E enolate, how we will draw the transition state? You can see that pH will be at equatorial position for benzaldehyde, at equatorial position, and this carbonyl is there, this is double bond O, and this is hydrogen for benzaldehyde, and I will draw this enolate in this fashion. You can see double bond O, Li, then this will coordinate to this, this will coordinate to this, will cyclic 6-membered transition state, and this will be 5-membered, and this is E enolate. How I can confirm this is E enolate? Because this bond and this bond are in trans, so this bond down and this is up, so down up is trans, so that is why this is perfect Zimmerman Traxler transition state for this attack. So now if you see the stereochemistry, this bond will become here and this will come here, and there is a formation of new bond here, so this will be product. If you redraw it, you will get anti and thioketone. So this pH is down and OH will be also down, and this is up. You can see this is up and this is down, so anti-product will be the major product. Now come to the next question. The following reaction is an example of. So the options are Cannizzaro reaction, Aldol reaction, retro-Aldol reaction, base catalyzed ring reaction. So the correct option will be retro-Aldol reaction. So if you retro this molecule, that is the product, you will get the reactant. How? I will show you that when you give NaH, that is a sodium hydride, that is a base, it will form enolate, and when it will attack to carbonyl carbon, and there will be formation of this, that is the reactant molecule. So this is a retro-Aldol reaction. For this much information for this video, so by this Aldol reaction is completed, and I will come with new examples of previous year questions of GATE, NET and other examination. So for this video, this much information is good. So thank you for watching this video, and please like and subscribe and share it to friends.